1. This may be something you remember, but maybe not. 4 is you are multiplying everything together. So you're taking this and multiplying it to both of these things. You're taking the -5 and multiplying it to both of these things. So because you're multiplying everything, you have 6x times -2x, which gives us -12x squared. 6x times 3 gives us 18x. -5 times -2x gives us 10x. And -5 times 3 gives us -15. Combine all your like terms and you get this -12x squared plus 28x minus 15. Do we have questions on that one? On number 2, we are combining like terms, so you would need to distribute everything and then combine your x's together and then your y's together. When you combine our x's together, we get -4x. When you combine our y's together, we get -3y. And that would be our final answer. Questions on that one? For number 3, we have to determine which of these points are not solutions. The easiest way to see that is look and see which of these points do not fall in this shaded area or fall on this line since it is dashed. 0, 3 falls on this line, so that would not be a solution because this line is not included. And 5, 1 does not fall in this shaded area, so both of these points would not be solutions. Do you have questions on that one? On the back. Number 4, you have to write an equation of this line that goes through this point and has this slope. So from what we recently reviewed last class, we could do this algebraically. You could also do this on the graph that's provided. So if you start at the point 4, -1, and use the slopes and go up 3 to the left 2, you'll get your y-intercept of 5. Do you have questions on that one? For number 5, you have to graph this inequality. So start at -1, and then your slope is +2, so you're going to go up 2 to the right 1 as many times as possible, or down 2 to the left 1 as many times as possible. This would be a solid line because it's equal to, and then shaded below, so everything below the y-intercept would be everything over here. Questions on that one? Today we're going to do the last objective before we take our quiz next class and then test on the first 3 review topics in this unit. So we're going to start off on this page. Make sure you have these notes in front of you, that you're writing them down. I'm not going to fill in all of this, but I am going to review some of the information. As we do this, one thing you need to remember is that parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. Negative reciprocals, if you have 2 different slopes, one of them is flipped, and one of them is positive, and the other negative. So if we were trying to find the negative reciprocal of 0, what would that be?
Positive.
That would be the same thing as this guy. So if I have this, all the numbers are over 1, and I take that and I flip it and I make it negative. What What would that be?
1.
No. Under 5. Because anything over 0 is under 5. So when we have 0 and undefined, those are going to be perpendicular slopes. You have to remember that. Questions on that part before we continue? For this, we are going to determine if these sets of lines are parallel to each other, perpendicular to each other, or don't have any sort of relation. To determine that, we have to find the slope of both of these lines. So we're going to use our slope formula, y2 minus y1 over x2 minus x1. So we're going to do this for both of these sets of lines, for AB and for CD. If you need to label these as x1, y1, x2, y2. And then we're going to find AB first. To set this up, we would do 6 minus 3 over 2 minus a negative 2. What would that slope be? 3 over positive 4. And then we're going to do the same thing for CD. Except this time we're going to do 3 minus 0 over 3 minus a negative 1. Yes. So if you wanted to change it to a plus, you could do that. What would that slope be? Same thing. So if they're the same thing, are these parallel, perpendicular, or neither? Parallel, because they're the same. If you had a positive 3/4 and a negative 3/4, those would not be parallel because they're not exactly the same. They either both need to be positive or both need to be negative in order for them to be parallel and be the same. Before we continue, do we have any questions on that process, or have we got that answered? We're going to do number 2. We'll do the same thing. Label them if you need to. For AB, this would be 4 minus 2 over 5 minus 0.
Oh.
What would this slope be? 2 over 5. And then we're going to do the same thing for CD. Three minus 8 over 3 minus 1. Negative 5 over 2. Are these slopes parallel, perpendicular, or neither? Perpendicular, because the numbers are flipped and one is negative, one is positive. If we had 2/5 and 5/2, or 5/2, those would not be perpendicular because one isn't negative. Or if I had negative 2/5 and negative 5/2, those again would not be perpendicular because one is not positive. So those would be neither cases. Do you have any questions on number 2 before we continue? We're going to do number 3 and then go to something else. For number 3, do the same thing. For AD, we have 6 minus 8 over 2 minus a negative 1 or plus 1 or well, that's like negative 2/3. And then for CD, we have 3 minus 2 over 3 minus a negative 1. What would that slope be? Are these parallel perpendicular? These do not have the same number. They are not negative reciprocals, so these are a neither case.
So what if the denominator is the same? Would it be parallel?
Everything would have to be the same. The numerator and the denominator, and if they're plus or minus or negative. So if just a piece of it is the same, they wouldn't be parallel. So like if we had 2/3 and I'm trying to think of something that wouldn't simplify 7/3, those would not be parallel. Are there questions on that one? On the next page, these circles are kind of jumbled up, but we're going to start number 9. Now we are given equations and have to determine are these parallel, perpendicular, or neither by looking at the slopes. For number 9, what is your slope of these two lines? 7. So if they are both 7, are these parallel, perpendicular, or neither?
Parallel.
Parallel. Good.
Number 10 perpendicular.
And would be perpendicular. These are negative reciprocal slopes. For 11, would those be parallel, perpendicular, or neither? Neither, because they look the same, but one's a negative, one's a positive, so they're not parallel. Keep that same energy when you actually take it.
Okay.
Now, if we're doing 12, can we decide if they're parallel, perpendicular, or neither just by looking at them? No. We have to solve them first. How would we solve this first one? We could divide by 6 and then we end up with a fraction for the x. Instead of doing that first, what could we do? Subtract x. And then we're going to take these two and flip them, so we have negative x plus 30. And then first and say that again. Now we can divide everything by 6. What would that final equation be? Not 6x, not negative 6x.
6.
We're dividing by 6. Negative 1 over 6 x plus 1. How would we solve the other equation? Divide everything by 3. So that equation would be y equals 6x minus 2. Now, look at the slopes. Would those be parallel, perpendicular, or neither? They're negative reciprocals. Remember that all whole numbers are over 1. You just don't see it. Before we continue, do we have any questions on that one? The x over 6, there's an imaginary 1 right in front of it. So instead of writing negative x over 6, which would be the same thing, we could write it as negative 1 6x. So those are the same thing. The last one we're going to do on this page is 16. We have a y equals some number and an x equals some number. We need to know the slopes of these two lines. What is the slope of y equals 6? 0. And what is the slope of x equals negative 1? What did you say? Not negative 1. 1? Not 1. It's a vertical line. It's an x equals. What type of slope will it have? So if we have a parallel slope and an undefined slope, are these parallel, perpendicular, or neither? Perpendicular. And you have to remember that these two things will always be perpendicular. If you forgot which one had which slope, but maybe let's say you remember this at least, you could draw these two lines. The y equals would be a horizontal line, the x equals would be a vertical line, and those would cross and be perpendicular. Do you have any other questions on 16? We're going to do 4 more. So we're going to do 4 more, and then you'll have time to practice. So on the next page, if we have parallel lines, they have, how do we know we have parallel lines? They have what type of slopes? You could say they have equal, either or. And perpendicular lines have what type of slopes?
Positive.
One will be positive, but there's a word for that. Okay, look back at your notes at the first page. Negative. Negative reciprocal slopes. So we have to keep those things in mind as we do these next 4. As we do these problems, so starting with number 1, You are given a point, you are given an equation, and they want you to write another equation that is parallel to the one they gave you. So first we need to talk about the slope. If the line D right is going to be parallel to this one, what would the slope be? Negative 4 will be the same. And then we're going to use the point they gave us and put the slope and the point into our point slope formula. I'm going to write that down just in case you forgot what that was. So our y minus y1 equals m times x minus x1. So once you have the slope and the point, you're going to put both of those things into this. The y is going to stay the same. Our y1 here is 7. Our m is negative 4. Our x would stay the same. And our x1 would be this negative 2. Before we distribute, we would need to take care of that negative negative and make it a plus. So I'm going to do that first. And then from there we can distribute. To get y minus 7 equals negative 4x minus 8. How would we solve this to get y by itself?
Plus 7.
Add 7 to both sides. So our final equation would be y equals negative 4x minus 1. This line is now parallel to the one they gave us. And we know it's parallel because they have the same slope, but different y-intercepts. Before we continue, did you have any questions on this problem? For number 2, we would start this off the same way, but can we find the slope of this just by looking at it? So we have to solve it first. How would we solve this equation? Put it back in slope intercept form.
Plus x.
Yes. So we have negative 3y equals, I'm going to switch these, x, I'm sorry, not plus.
Yeah, it's minus x.
Negative x plus 9. And then divided by negative 3. So all your signs are going to what would this equation be? 1 x minus 3. 1 third x minus 3. That is not our final answer. That is just us rewriting the original into slope intercept form.
You have to simplify.
We will now need to take that slope and do the same process we did before. So if we were to write another equation that is parallel to this line, what would the slope be? 1/3. It wouldn't change. We're going to use this point, x1, y1, and put that back into our point slope formula. We have y minus, our y1 is negative 1. Our slope is positive 1/3. minus 3. And then we would continue solving. So we would need to make this side a plus and distribute. We can do that at the same time. When we distribute this, what would we get on the other side? 1/3 x minus 1. And then we would do what to get y by itself? Subtract 1, but it's going to be this one that we're subtracting. So our final equation would be y equals 1/3 x minus 2. There are a couple people out right now, so it's not going to do we have any questions on that?
So, I'm confused about how you got how you had to put the negative.
Yeah.
Basically, you just switch on numbers.
With this one,
Yeah.
that's our y value. So anytime you put numbers in, you're always subtracting no matter what. Since it was negative and you were subtracting, that became a plus. I don't know if that's what you were asking though.
Oh, no, I see this.
For number 3, we're doing the same thing, but now we're looking for perpendicular. For this one, we are given this equation, given this plane. We have to find or write a new equation that would be perpendicular to this one. What would the slope of that line be? Negative 1/2. So we're going to use that slope and the point they gave us and put it back into the slope or point slope form. So we have y minus 3 equals our new slope, not this one, but negative 1/2, x minus 4. And from there we would do what?
How do you trigger?
How do we get? Which one? We have to look at the
Uh,
negative reciprocal of the original. So if we look at this original, and since it's perpendicular, we're going to take that number and flip it and make it negative. It depends. If it's already negative, you would make it positive. If it was positive, you would make it negative. But only for perpendicular, not for parallel. What would we do next here? Distribute. We have y minus 3 equals, what would this side be when we distribute? Plus. And then we would add 3 to both sides. So that our final equation would be y equals negative 1/2 x plus 5. What questions did we have on that one? We are doing mostly the same things, but the slope is different, so that part is different. So the method to solve it is the same. How we put the point in is the same, but the slope part at the beginning is different.
Oh, because the x is in the front, right?
Because it's perpendicular. For number 4, would we be able to find the slope as is? No. No. We have to solve it first. How would we solve this? Subtract 5x from both sides. We have 3y equals negative 5x minus 21. And then divided using by 3. We have y equals negative 5 over 3x minus 7. And then that is not our final answer, that is just us rewriting this one. And now we need to find the slope that if we're writing an equation perpendicular to that one, what would our new slope be? 3 over 5.
Okay.
Wait, so the negative 5 we drop that down.
We take that and flip it and make it positive. So for perpendicular, you're never going to use the slope that's given. You're always going to use a negative reciprocal slope. Right, so then we can use that slope and use our point and put those both into our point slope formula. We have y minus 1 equals our slope of 3/5 times x minus negative 5. What would we do first? And then distribute. So y minus 1 equals 3/5 x. What would we get when we multiply 3/5 and 5? Someone do that in your calculator, see what you would get. Should be 3. Add 1 to both sides, and you get y equals 3 over 5x plus 4. Bless you. Bless you. You guys are like sneaking around. Do we have any questions on how we got that? For this? So once you have your new slope and your point, you can plug them in. So if you solve this and immediately plug this in, then you did the wrong step. You look at this slope, says given, and you flip it, and if it's negative already, you make it positive. If it's positive, you make it negative.
That's all it is, it's perpendicular.
Correct. Say that one more time.
It's a 3.
Yeah. I don't know why it looks like that, but. Do we have any other questions on this stuff? Mr. Norfolk, you wanted to say something?